All right, so let's talk about the next one, which is 202. This is Wireshark. Wireshark, I mentioned before, is a program that's very important. And you can just install it right on your operating system on any machine you want, Mac, Linux, or PC. I probably already have it on this machine. I do, Wireshark. You can just download it and put it on. And here's the evidence file. We're going to use the same evidence as the previous one, because remember I mentioned there was a disk image, which we just looked at with autopsy, but the other files there were in fact packet captures. So I'm going to save this in downloads on my Mac, so it's going to look a little different than the PC I was using before. And then in my downloads folder, on the Mac, you can just double click it to unzip it. Doesn't work on Windows because Microsoft is cruel, but it works on the Mac. So now I have a case 1 folder, and in there are several files, and these log files are in fact packet captures. I don't know why they have a non-standard extension, but they do. So now we can just open rhino.log in Wireshark. Normally, one common use of Wireshark is to sniff live traffic off the network, although that is not recommended. Wireshark is a very powerful, very easy to use program, but the reason it's so powerful is that it knows every possible kind of network traffic and it dissects it. And it does that using contributions from random users that just write dissectors. So the dissectors are like Firefox extensions. They're not necessarily well written. So Wireshark is a security risk if you sniff live traffic. There are often ways to take over the machine through. So it's generally considered a best practice to use Wireshark the way we're going to use it here to analyze saved packets that you got somewhere else, not live network traffic. Although you can do it that way, it's better to use TCP dump for that. So I can just open a file here with File Open, and then go to Downloads, and Case 1, and rhino.log. And there it is. Now I see a bunch of packets. At the bottom right, it'll show me I have 6,557 packets. And here they are. And you can examine packets one by one in Wireshark. This is not considered the best way to analyze them usually, but you can see here, here's a SYN/ACK making a connection to something on port 80. Here's a GET loading a web page, and so on. So these are the packets for some kind of traffic. And now let's go see what we want to find out about this. Okay, the first thing, we want to look at Telnet. So Telnet is a protocol, and as I mentioned, the main reason people love Wireshark is that it understands everything about every protocol. So you can just put anything in the display bar here. If it's red, that means your command is not understood yet. When it turns green, you've got a command it understands, like Telnet. When you press enter, it will filter for only Telnet packets. Telnet is a really old protocol. It originally was used to control machines with a wire in your room to connect a terminal to a host. But they ported it to the internet, so you're remote controlling devices over the internet, and it's sending your characters with no encryption over the internet because it was a really old protocol. So it is very unsafe. It is still, however, used quite a bit. So we're going to take Telnet, and this is the wrong, okay, let's see. Somehow I'm in the wrong part here. All right. So we find Telnet packets, okay. Now we're only going to have 568 packets, and we're going to export those packets and call them Telnet. And then we're going to find FTP the same way. All right, so let me go back to here. So if you look in the corner, I have packets 6857 displayed 568. So I'm only looking at 8% of the packets here. So I'm going to export this file, export specified packets, exporting the displayed packets, and I'll call that Telnet. All right. Now I want to export, I think, FTP the same way. Yep, with FTP, all right. FTP is File Transfer Protocol, which is another really old protocol that also sends data without encrypting it on the internet. So FTP, I've only got 50 packets of all those packets that were FTP, and I'm going to save them. Export specified packets as FTP. All right. In this particular case, it's not necessary, but it's often good to cut a big PCAP into pieces to analyze it one piece at a time. So now I've done that, I can examine the Telnet traffic by opening just that file, and then I can follow the TCP stream. So let's do File Open, and open telnet.pcap. Now I've got just those packets, supposedly, and I've got the FTP filter is still on, so I can't see them. I've got to get rid of the filter and press enter. Now I can see them. Now, I can right-click this and follow TCP stream. This is extremely useful. Right now I'm seeing the packets the way the machine sees it, with addresses one by one. This gives you the data the way the user saw it. You see just the red is being sent from the server and the blue is being sent up to the server. So what the user typed is in blue, what the computer typed is in red. So it's very nice. This is Sun OS, some really old operating system. Then it's time to log in. Here they type in with the name GNOME, so they type each letter and it echoes back from the server. Then they put in a password, which is GNOME12, but login is incorrect. Then they try logging in again. A better password gets in, then they get in, they see a system, then they execute a few commands, like listing the files on the server, and so on. So you can read through this and see what they've been doing on the server. So, read through the data, they log out. Now that's only one stream, that's only one session, which would be a series of packets. There's a stream counter down here. I can go to the next stream, and now I see the next time somebody tries to log in and they didn't get in. Then I go to the next stream. So just like you can go from one email to the next in Autopsy, you can go from one stream to the next, and this way you don't have to see the addresses or the individual packets. You see what the user saw. So it's pretty easy to read through it and find out what they were doing. All right, and so I think there are tags here. The user leaves a message to John in a file, so you have to find this file. They'll find it in one of those streams. And I think this image even gives you a clue, which stream it is. So it shouldn't be too hard to find. There's a flag defined in there. And then you repeat it to do the FTP traffic, which you just saved. The user transfers some files, and again, you follow the stream, and you find the name of a file that was transferred. So now we can extract images. They transferred images over the network, and we have the data from the network, and it was not encrypted, so we can extract the images. However, Telnet doesn't move images, and FTP doesn't move images. The FTP traffic, labeled FTP, is control traffic. The actual data is FTP data. So we got to get the FTP data out of here. So let's open the original file, which was rhino.log, and now filter for FTP data. All right, there's 338 FTP data packets, so I'm going to export those, export specified packets, and call that FTP data. And then open just that one. You don't really have to make them in a separate file, but I find it's easier to keep things organized. All right, now I've got the FTP data. I don't need to filter anymore. And now, the TCP stream will show the data. So let's take a look at the TCP stream here. Follow TCP stream. Okay, notice what's going on. See this JFIF? That is the mark of a JPEG. A JPEG starts with JFI, joint something or other, and then you see it even has Photoshop in there. Like I said, there's metadata in JPEGs showing extra information like the program you used to save the file and so on. This is random stuff. That is the actual image. And at the end, there'll be a footer, which may not be readable either. It's not obvious. All right, so this is an image expressed as ASCII, and a lot of it is unprintable characters that show up as dots. You can save this image right from there. And the way you do it is in here. Okay, you switch to RAW and save it as a JPEG. So down here, it's showing data. Let me see if I can get this to go higher on the screen to be more visible. I might not be able to. Let's see, I can drag it to the left. Ah, there we go. All right. So down at the bottom, it says show data as ASCII. I have to change that to RAW. Now it shows it as raw hexadecimal. This is the raw binary data. This has everything in it. Now I can save as, and this will just save that as a binary file. So I can put it in, I want to make that bigger. It's not letting me do it, all right? Let's see. Seems to be freezing up on me. Let's give it a name. It does seem to be freezing up on me. I'm going to cancel and try again. Oh, the whole thing is somehow froze up on me. How rude. Cancel does nothing. Right. Can't quit either. Okay. This probably means it's opened up some kind of box for me to answer and I can't find it. That's usually what it means when foolish things like this happen. I'm just going to forcibly quit Wireshark because somehow I can't make it respond anymore. All right. It'll be easy enough to get back to where I was. All right. Wireshark. It's probably got to do with my projecting things on this projection screen, which is small. There's probably some message appearing off the screen that I can't see, which is pretty common. So I go to, it forgot the recent files because it didn't go through a proper shutdown. So I have to go to Downloads, Case 1, FTP data. Okay, right click, follow, TCP stream. And here's the image. It probably didn't like me resizing this window. This is another thing about free software, open source software. It often has strange bugs. So I'll go to raw, and then I'm going to save as. For that, I got to move it off that screen over to here where I can see the save as button, which is too far off the screen to reach there. Oh, I'm zoomed in a little. Might be all right now. Oh, there, now I can reach the save as button. All right. And good, now it's letting me do it. So now I can save it as, I think I even said in the project what to save it, Rhino 1 or something. Yeah, rhino1.jpg, rhino.jpg. And, oh good, in the case 1 folder, that would be fine, save. All right, now you can open that file. Just go to there, and there's rhino1.jpg. You can double click it and open it in a photo viewer. And there it is, a picture of a rhino, the forbidden picture. Anyway, so that's the game. So you can find the MD5 hash of it, and then you can find more things. You will find a zip archive. If you go through more streams, you will find a PK zip archive, which does not start with JFIF, it starts with PK, which is the initials Phil Katz of the guy that wrote the zip algorithm. And so you save that the same way, and it's a password protected archive, and you have to crack it. And there's an online site to crack zip passwords by just trying. There's also tools like fcrack, zip, and stuff. And so that's for extra credit. You can get into that password protected archive. So that's analyzing network data. That's one thing you do not do with Autopsy. Wireshark's a better tool for that. And there are other tools, yeah.
Does Autopsy have a tool for that?
I do not think Autopsy has a network analysis tool, as far as I know. It might, but I wouldn't bother because Wireshark is the standard, and another thing a lot of people like, I forgot the name, there's another one a lot of people, forensic people like, may come back to me, yeah.
Pineapple?
Pineapple? Pineapple? Oh no, well the pineapple is a hacking tool. The pineapple is for attacking living people. You put a pineapple in the room, and it will put up fake access points, and when people connect, you can hack their machine. So that's a pen testing tool, not a forensic tool, really. There's another forensic tool, though, that finds images and sorts them out of PCAPs. I'll remember it eventually.
If I have a device that's still running, like still turned on, is there a way to locate packets that have been sent by that device?
If you have a device, well, if it's currently sending packets, then actually, if you had like a wireless device sending wireless packets out, then they don't go very far. They're pretty much line of sight. So you can pretty much tell what room they're in by where you can connect them. But if you wanted to locate them within the room, that's actually very difficult because it bounces off the walls and ceilings and everything. So even a direction finder, it's very hard to find. So this is why there's a stunt. You can go into like a big conference and you can start emitting deauth packets, and you can shut down the wireless so nobody can use it, and nobody can do anything about it because there's no authentication in deauth packets, and there's no way they can find you. So you can mess everybody's day up.
But I guess what I'm saying is if you have a machine, is there any log stored on the machine that like logs what packets have been sent from that machine?
Oh, logs of packets sent. I don't think so, but programs will keep logs of what folders you're opening and what files you're opening, and we'll see a lot of that in Autopsy. It doesn't record it packet by packet, though, but there would be logs from the software you're using in most cases, but it would depend on the software. Like if you wrote a custom script to send out traffic, then it might not keep any logs. Is the other forensic, so not CyberChef. No, CyberChef is just a mathematical tool to analyze things. There are other tools just to forensically analyze network traffic. But I'll tell you next time. I can't remember the name of it now. I don't use it much. Never liked it very much, but other people like it. Let me stop the recording.